Hello students, good morning to all. Nowadays, see the topic motional EMF from Lorentz force. AB is a straight rod and its length L in uniform magnetic field perpendicular to plane of paper. Let rod move with velocity V towards right side. The free electrons present in it also move with the same velocity V in magnetic field B. The Lorentz force is F B vector is equal to minus E into V vector into B. E means free electron. E means free electron. V means velocity. B means magnetic field. Due to electric field E vector, the Coulomb force acting on free electrons along AB. So, the Coulomb force is F V vector is equal to the Coulomb force is F E vector is equal to minus E capital E vector. So, the Lorentz force and Coulomb force are balanced to each other. Now we get the modulus of F B vector is equal to the modulus of F E vector. So, F B vector and F E vector, the values are substituted. You are all already known these values. So, the modulus of minus E bracket V vector into B vector is equal to the modulus of minus E capital E vector. The minus E cancel. V vector into B vector is cross multiplication vector function. So, V vector into B vector is equal to VB sin theta. Theta is 90 degree equal to sin 90 degree is equal to 1. We get E is equal to VB. The potential difference of AB is V is equal to capital EL. E is VB. So, V is equal to VBL. Now, the motional EMF psi is equal to BLV. Next one, the current I is equal to the motional EMF psi by R is equal to the value of psi is equal to BLV. So, BLV by R. That's all. Applications of eddy current. The first picture is induction stove. Induction stove is used to cook the food quickly and safely with less energy. Below the cooking zone, the coil of insulated wire is wound tightly. Cooking pan is placed over a cooking zone. When the stove is switched on, AC current flows in the coil. It produces high frequency alternating magnetic field, which induces strong eddy current. It produces so much of heat used to cook the food. Next one, eddy current brake. It is used to in high speed trains and roller coasters. Strong electromagnets are fixed above rails. When brake is applied, magnetic field induced eddy currents in rail which oppose or resist the movement of train. In some cases, circular disc connected to the wheel of the train. Then there is relative motion between disc and magnet. Eddy current is induced in the disc which stops the train. This is eddy current circular brake. Next one, eddy current testing. It is used to find defects like surface cracks, air bubbles present in a specimen. Alternative current passes through insulated coil. Alternating magnetic field is produced. When coil is brought near test surface, eddy current is induced. Presence of defects cases change in phase and amplitude of eddy current. In this way, defect in a specimen are identified. And another one, electromagnetic damping. Armature of galvanometer coil is wound on a soft iron cylinder. Once armature is deflected, the relative motion induced eddy current in cylinder. The damping forces due to eddy current brings armature to testing immediately. Then galvanometer shows eddy current deflection. That's all. Self-inductance. Now see the picture. N pi b is proportional to I. Let pi b be the magnetic flux linked with each turn of the coil of n turns. Then the total flux linked with the coil Nb is proportional to the current I in the coil. So N pi b is equal to Li, or L is equal to N pi b by I. The constant of proportionality L is called self-inductance of the coil. It is also referred to as the coefficient of self-inductance. If I is equal to 1 ampere, then L is equal to N phi V. Self-inductance or simply inductance of a coil is defined as the flux linkage of the coil when 1 ampere current flows through it. So psi is equal to d of n phi b by dt. So psi is equal to minus d of n phi b by dt is equal to minus d. N phi b is equal to Li. So minus d of Li by dt. So psi is equal to minus L into di by dt. Now you only get the value self-inductance L. So L is equal to minus psi by di by dt. The negative sign is the above equation means that the self-induced EMF always opposes the charge in current with respect to time. If di by dt is equal to 1 ampere second power minus 1, then L is equal to minus psi. Inductance of a coil is also defined as the opposing EMF induced in a coil when the rate of charge of current through the coil is 1 ampere second power minus 1. Unit of inductance. Inductance is a scalar and its unit is Weber amperes power minus 1 or volt second power ampere power minus 1. It is also measured in a Henry. 1 Henry is equal to 1 Weber ampere power minus 1. So 1 Weber ampere power minus 1 is equal to second ampere power minus 1. So the dimensional formula of inductance is meter ml squared second. The dimensional formula of inductance is ml squared t power minus 2 ampere power minus 2. If I is equal to 1 ampere and n pi of p is equal to 1 Weber. 1 Weber turns, n pi of p is equal to 1 Weber turns, then L is equal to 1 H or inductance equal to 1 Henry. Therefore, the induction of the coil is said to be 1 Henry if a current of 1 ampere produces unit flux linkage in the coil. If di by dt is equal to 1 ampere second power minus 1 and psi is equal to minus 1 volt, then 1 Henry. Then L is equal to 1 Henry. Therefore, The inductance of the coil is 1 Henry if a current changing at the rate of 1 ampere second power minus 1 induces an opposing EMF of 1 volt in it.